Recording started.
Welcome to this session for Algebra 2 on Foundations. We are going to look at solving absolute value equations, adding, subtracting, and multiplying integers, and dividing fractions and whole numbers. And before I get started, those of you who are new to these recordings, in the lower left-hand corner, you can see that you can pause, rewind, fast forward, just so you know you can do those things when you're watching these. So we're going to look at absolute value and what it is. Hopefully you've worked with absolute value in the past. If not, we're going to write a definition here, or if you just need to refresh your memory. Absolute value is the distance a number is from 0 on the number line. So you're looking at the distance a number is from 0 on the number line. So some examples that we're going to take a look at are the absolute value of 25 and the absolute value of negative 25. Well, hopefully you'll notice that the distance that 25 is from 0 on the number line is 25. And then if we look at this one, the absolute value of negative 25, we're asking the same question. What is the distance from negative 25 to 0 on a number line? Well, distance is always positive, so it's a positive 25. Now, the only time you may get a negative answer when you're working with absolute value is if you have a problem like this. The absolute value, or the opposite of the absolute value of negative 25. So when you have a negative sign outside the absolute value, that's going to give you a negative result. Because if we take the absolute value of negative 25, we just said it's a positive 25. But you have this negative sign out here, which gives you a negative 25 as an answer. So we're not saying that the absolute value is negative 25, we're saying the solution to this problem is negative 25. Moving on to adding integers, I have the same numbers here in a bunch of different situations. So we're going to look at the first one, negative 4 plus 6. Now, some students like to use a number line to add and subtract integers. Some like to think of a thermometer, temperature. If you're at negative 4 degrees and you add 6 degrees, what's your temperature going to be? You can figure these out in any way that you like. The rules for adding integers, when one is negative and one is positive, you're always subtracting. So 6 and 4, if I subtract them, I get a 2. And then we have to look at the signs. We look at which number is larger, the 6 or the 4. The 6 is larger, and whatever sign it has will be the sign of my answer. Since it's a positive 6, my answer to negative 4 plus 6 is a positive 2. Then if we go down to this one, 4 minus 6, if you remember, you can write a subtraction as an addition, and it will be 4 plus negative 6. The 6, whatever sign is in front of the number, is the sign for that number. So the 6 is actually negative. So we have opposite signs, one positive, one negative. So we again subtract, and we look at the two numbers, which is larger, 4 or 6. 6 is larger and it's negative, so our answer is then negative. So when you can think of temperature or number line again, if you have 4 degrees and you subtract 6, you're going to be in the negatives. And I definitely would not want to be anywhere near a place that is at negative 2 degrees. Still enjoying summer. So we get negative 2. Then if we go up to negative 4 minus 6, that can be written as negative 4 plus negative 6. When both are negative, you're always adding, and your answer is always negative. So we get negative 10. Then 4 minus negative 6 is what's called a double negative. Oops. Trying to write that out, didn't come out very good. Apologize for that. Double negative. Here's my yellow over a little bit. So that becomes a positive always. So it becomes 4 plus 6. And we get an answer of 10. So rules, we write out the rules here. This is for adding, subtracting. When one is positive when one number, I'm kind of shortening a little bit, when one number is positive and one is negative, you always subtract, and your answer is has the sign of the larger number. And then when both are negative, both numbers are negative, you always add, and your answer is always negative. So the only part that really gets tricky is this first rule, because it depends on which number or the sign of the larger number. So your answers, the sign for your answer is going to be dependent on the sign of the larger number. But for when they're both negative, you're always adding, it's always negative. Let's look at some dividing. And remember, you can go back and pause or rewind if you need to that previous slide. 3/5 divided by 4. If you remember working with fractions and division, we always change the division symbol to a multiplication. And we always write the reciprocal of the second number. So what I'm going to do first, before I write that reciprocal, since it's a whole number, I'm going to write the 4 as 4 over 1. So any whole number can be written over 1. So then I change the division to multiplication, and I write the reciprocal of 4 over 1, which is 1 over 4. So you're switching your numerator and denominator. Then I multiply my numerators and multiply my denominators, and I get 3/20. Then for 4 divided by 3/5, I'm going to write that as 4 over 1. Division becomes multiplication, and 3/5 becomes 5/3. Multiply numerators, and I get 20, and multiply denominators, and I get 3. So I get 20 over 3. Then 36 divided by -9, one's positive and one's negative. So when I'm dividing or multiplying and one's positive and one's negative, I'm always going to get a negative answer. So my answer is going to be negative, and I'm taking 36 divided by 9, which is 4. So I get -4. So my rules, we're going to write the rules for multiplying and dividing. When both are negative, answer is positive. When one is positive and one is negative, answer is negative. And these are always the case. When they're both negative, your answer is always positive. When one's positive and one's negative, your answer is always negative. So these rules apply all the time. And that's it on the foundations.